So it's talking about the interior angles of a polygon. And I know to find the total of the angle measures, it's 180 times the number of sides minus 2. But to find the measure of one angle in an n-gon, then I would have to divide by n. And I know the measure of one of those angles is 165.6 degrees. So this will give me the measure of a single angle in an n-gon, single interior angle, and a regular n-gon, and I know that it equals this. I'm going to multiply both sides by n to get rid of this divide by n. That's going to make this side 165.6n. I'm not going to worry about putting the degrees on my work. And at the same time, I'm going to distribute this 180 over here to make this 180n minus 360. Now, I'm going to subtract the 165.6n to move it over here, and that's going to give me 14.4n on this side. And I'm going to add the 360 to get the constant to the right to make this a positive 360. Now, when I divide both sides by 14.4, I get n equals 25, so 25 sides. Don't forget to label your answer. It said how many sides? That many sides. This is a problem you saw in your homework, but it behooves you to go back and look sometimes at these and try them again. If you struggle with them, people have me working these out in class and talking about them, so you need to work them fresh. You don't have to find these things in alphabetical order, but what I would expect, this particular one doesn't ask you to give your justification, so you don't have to do that. You do still need to show your work and show me the order in which you found things. So A is a really quick 116 because it's a vertical pair with this 116 degree angle. Now, to find B, I can't directly find it using things that I knew before, but I can find it directly using something that I know now. This is a trapezoid because these two sides are parallel, which means A and B have to be supplementary, so B is 180 minus 116, and I don't even think I did that when I did the answer key for this, because I found the measure of angle 1 here somewhere, and I don't have to do that. Now I know that these two consecutive angles that are between the bases of a trapezoid are supplementary. So B is 64 degrees. I'm going to mark that in. 64 degrees, 116 degrees. So for C, and I have to look on the picture and see where C is and see if I can find that next. Yeah, these two have to be supplementary. That's 90 degrees. So C has to be 180 minus 90, which means C has to be 90 degrees. D is over here. This is a quadrilateral. So I could use the quadrilateral sum theorem, conjecture, or I know that D and the 98 degree angle have to be supplementary because this is a trapezoid. So D, and again, I'm not sure I did it this way in my answer key, but it makes sense to me now. D is 180 minus 98, which means D has to be an 82 degree angle. Now, for E and P, if I look at this larger pentagon out here, and I think I'm not going to outline it right now, I know that the sum of the measures of a pentagon has to be 540 degrees. So E equals P, because if those angles are congruent, the measures are equals 540 minus the 116 minus the 138. Oops. You know what? I did not mean to do that. And you're probably saying, why did she do that? You're right. I wanted to look, instead of that big pentagon, I wanted to look at this quadrilateral. So E equals P equals 360 minus the 98 minus the 64, and then divided by 2 because those angles are congruent to each other. So 360 minus 98 minus 64 divided by 2 means that E and P are both 99 degrees. So these are 99 degrees, which means F I can get using that trapezoid part that I wanted to, either with these two up here or this smaller trapezoid here. It really doesn't matter. I think it's easier to say F then is the 540, which is the measures of the interior angles of a trapezoid, minus the two 99-degree angles, minus the 116, minus the 138. So F ends up being 88 degrees. G, using the the definition of a degree, which again is kind of a loosey-goosey thing to do. We know that these three together have to be 360. So G is 360 minus the 88 we just found for F, minus the 122 that's already there, which makes G 150 degrees. H, let me mark these in, 150 degrees and 88 degrees. To find H, I have a couple of choices, and I don't actually have to find H next. Well, to find H, I know that this is a 64-degree angle, so I can say the measure of angle 1 is 64 degrees. Measure of angle 2 is 90 degrees. Again, I didn't have to do it this way. So H is 360 minus the 150 that is G, minus the 90 for measure of angle 2, minus the 64 for the measure of angle 1, which makes H 56 degrees. J, well, 3, the measure of angle 3 is also 90 degrees. So J is 360 minus the 87-degree angle down there in the right corner, minus the 77, minus the 90, which means J ends up being 106 degrees. I don't have anything directly for K. I have options though. Probably I'm going to make this an angle 4. So the measure of angle 4, since it's a linear pair with J, is 180 minus 106, which means the measure of angle 4 is 74 degrees. Since K is an alternate interior angle with that angle, and these are parallel lines, K is also 74 degrees. At some point, I need one of these angles. I'm going to do this one. I'm going to make this angle 5. So the measure of angle 5, and I'm running out of room here, so I'm going to go up here. Measure of angle 5 is 90 degrees because it is. If these are perpendicular, that has to be 90 degrees. So to find n, I'm going to use this quadrilateral. So 360 minus the 36 minus the 116 minus the 90 means that n is 118 degrees. So using the definition of a degree, again, sort of very loosely, m is 360 minus the 118 that I just found, minus the 106 that's already there, and m ends up being 136 degrees. Now the last problem on this one, all of the exterior angle measures, the sum of the exterior angle measures of any regular polygon, or of any polygon, is 360 degrees. Regular ones, all of those exterior angles will be congruent to each other. Well, if each angle is 4.8 degrees, I can take the 360 divided by 4.8 to find that this thing has to have 75 sides.